And there's a lot of cool stuff coming out in the last couple of years for server-side JavaScript. We're going to touch on both, and we're going to touch on some 3D, so some graphic stuff. There's different renderers. We're going to just pick one of them and keep it nice and simple. I have about 400 lines of presenter notes here, and we've got about 600 lines of code to go through live. It's going to feel like a lightning talk for the whole way through. But interrupt me if you like, that's fine. So, I've been a PHP developer for a long time. I'm a Cake PHP core developer. So primarily I'm dealing with PHP. I also do a lot of C# stuff. JavaScript, we'll get to my skills in that in a sec. If you want to grab any info about me, grab me on Twitter. I'm always saying something silly on there. I'm a tragic gamer. I've been a gamer for a long time. I used to work as a gaming administrator for an ISP in Sydney, and that was great. Able to meet lots of the community and do some cool stuff. I used to game competitively as well, so this is where my interest in 3D sort of comes from. I want to build my own games. I've got my own ideas. I've got a hobby in game development. I like to do research and development, so get something working, proof of concept, and then move on to something else. You know, maybe one day I'll have all of these cool tools and I can build up something useful. Doing something like this makes me a better developer for work, because I can do different and interesting things. So I have a few side projects. When I stop work for the day, right on 5 PM, I'm still coding because I'm doing my side projects for probably 10 hours of the day. So I've got this one called My Island. That's the name I've given it for the moment, and it lets me do a few cool things. I'm terrible at math, and I'm actually scared of math, so this challenges me a bit. It's using Perlin noise generation, and it's got a simplex noise generator as well. I love noise generation too. If anyone wants to talk to me about it, come and talk to me. Voxel-based terrain, if anyone plays games, this looks kind of like Minecraft terrain. It's got complex mesh generation and combination for performance, but it still has some performance complexities. This actually has a fairly complex interior cave system as well. It's an interesting thing to be able to do procedurally. The other thing that I've done, and this was actually 2 days ago, is I've got myself a good example of sphere tessellation, and that is procedurally generating a sphere, which is an interesting problem. It can be simple, but if you want to do it, you can see here I've got different resolution essentially for the mesh, and so I'm generating that manually, and it's actually quite performant. It's just an interesting problem to try and solve to get these meshes happening manually. One of my more interesting ones, I think, is the procedural terrain generation for planets, building a space sort of game. Trying to make them Earth-like, so they're primarily water, but they're a little bit chunky, so they're kind of cartoonish. That means I don't have to go into too much detail to make it realistic. It makes it easy for me. It exposed me to things like shaders and colouring, which was new to me. I've got this one that I call Space. I can't think of any other name for it, but it's a free-form sandbox game, and I'm using a different style of planetary generation with Perlin noise again, and it looks kind of like a planet, I think. Well, I think. It's got intra-atmosphere travel, so you can actually travel into the planet's atmosphere, and it's got gravity for the planet as well. That's kind of interesting, and a mate of mine actually did the model of the ship for me. One of the first JavaScript things that I was asked to do was for my girlfriend. There was a falling sand game for the iPad, but it cost money. So she wanted one that was free. She loves these things. So you can actually tell it how many generators you want, and you won't be able to see it. Oh, you can see it. There's tiny little particles falling down, and they stack up. That's quite good. That's very performant too. You can drag those handlers, those generators around. You can change the colours. I went to an Apps for New South Wales event. It was run by the government to build apps on their data. So it was from data.gov.au. It was a New South Wales one. They had some LiDAR data from Kempsey, and what this LiDAR data did was classified whether or not it thought something was man-made, natural like a tree, or if it was ground. Now there's a few other classifications as well. This is a half-working, exactly half-working to be exact, example of. Yeah. But from this you can see it's plotting points, and it's putting that LiDAR data, it's loading it procedurally, so it's pulling in data as it can. And you can see like a natural formation of a road, and you can see a bend in the road there and the houses, and that was quite fun. So the scary fact, and why I will understand if people want to leave. I am not a JavaScript ninja. I am, if you're using JavaScript day to day, you might be better at JavaScript than me. And that's fine. The exciting fact and why you should stay is that even if you're not a JavaScript ninja, you can create some pretty cool stuff. And it's kind of fun, and it extends your skills and lets you do some interesting things. There can be problems along the way, though. This is an example, well, one of the first examples that I had of planetary terrain generation. So don't be discouraged if you come up with some unusual results.
I believe they found that orbiting outside the orbit of Neptune.
So I'll go over a bit of the technology that we're using today. We're going to use JavaScript in the browser. I did say Chrome there. I was using Chrome before, but we'll use Firefox or Safari. 3.js is an abstraction above rendering techniques, so WebGL and Canvas 3D. It makes 3D easier. There's a link here, so github.com/MrDoob. Node.js for a server, and it's going to handle client management. Does anyone use Node.js? Hands up. Yep. One. So those that know JavaScript, you know how to use Node.js already. So you should have a look at it sometime. So math, again, I am actually scared of math. It terrifies me. But we're going to talk about vectors, quaternions, matrices, and a little bit of trigonometry to get you the basics of how to deal with 3D space. You two guys in the front are in a really bad position because I need volunteers in a sec. So this is a vector. This is a... well, I can use these guys too if you like. So this is a 2D vector. Basically, it's a point in space to another point in space. It represents that distance and has direction. So from point A to point B is the vector AB. It has direction. We need this to be able to address space. So we can talk about it as a point. Point with an X and a Y coordinate, and there's a couple of examples there. So 12, 13 is X12, Y13. A 3D vector just adds a Z component. This is slightly off the axis that we'll be using. We use X going to the left, Y goes down, and Z goes into the screen. So 3 coordinates to allow you to address objects in 3D space. Okay, volunteers? Okay, so there's 2 concepts of space. There's local space and there's world space. Need a bit of, okay, so we're going to create an object in a game, and I'm going to place you into the world space. Okay? That's all you need to know right now. You've been placed into the game, and you're also in world space. Right. Okay? I've been placed into the game, but I'm being placed into the local space of you. Okay? So I'm just going to put my hand on your shoulder. And so move around a bit. Go for a walk. So he's moving around in world space. Doesn't affect anything or do anything. He's moving around, that's fine. If I move around, that's fine too. I can move around, that's not a problem. But I'm moving around relative to my parent. I'm in this local space. I have a world space position based on his position. So if you move, I'm going to move with him. I have a local space relative to my parent. So, and it's also for rotation as well. So if you rotate, I would rotate around. So that's all I needed. Thanks for that. That demonstrates. I was thinking last night, how do I demonstrate local and world space really quickly and simply? So the objects that we need to manage, we've got objects that we want to display. So we're going to just use a couple of geometric shapes. The ones that we want to display, we need to add to a scene. And generally you have a fairly complex scene manager, but we're just going to throw them on the scene for starters. That scene needs to send its information to a camera or be viewed by a camera. In a lot of cases you need to add the camera to the scene as well. That camera then sends its information to a renderer, and that renderer can then output the result. And the reason that it needs to go to a camera and do that is, I didn't include the slides. There are different types of cameras that you can use. There's generally be using a perspective camera, so you want to see objects that look kind of like they look in the real world. But you might want to use an orthographic camera, which would have it's a different perspective. Things look like they look like in technical drawings. They don't look like, if you saw a orthographic represented object and it was in a perspective world, it would look really, really odd. It's very boxy and weird, doesn't look right. So for real 3D experiences, we generally use a perspective camera. So the concept for a game, we're going to build a game, it's going to be multiplayer, fairly responsive, and we're going to use a canvas-based HTML renderer. Time for some code. How are we doing for time? Okay, that took twice as long as it should have. That's fine. So, I've downloaded a few things earlier, so what we need to do first, we're going to grab 3.js. I'm just going to copy it from an existing one that I've got. So I've just made a JS directory. I would download 3.js. Okay, so I've just downloaded it, in theory. So I've got 3.js, and I've got a custom folder which has the 3 canvas renderer, the 3 WebGL renderer, and other renderers, but it needs those as well. So I've just downloaded that package and thrown it in a JS directory. At the top level, I'll create an index.html. Okay, very, very simple. Believe it or not, you do need a title. Okay, and for the body, we're not going to include anything right now. So we'll just make sure that that works, because I really should test my browser. Okay, so it's got the title. That works fine. So we're going to start with a basic HTML page.
Is that the /JS/index?
No, we put the index outside of the JS directory. So the index is here. JS. Yep. So what we just basically need to do is include the 3JS and our own scripts that we're going to create. And we're actually going to do it in the body. That's our best preference, to include it in the body. So it loads in the right order. So include 3.js. And we're going to create our own script as well. So call it client.js, okay, which we'll just quickly create. New file, client.js. Okay, doesn't do anything yet, but that's fine. So that's working. What we might do first, we've got the basic file there, so we can start building out the client. Might quickly jump on and create a basic server, so a Node.js server. So we get clients to connect to it, manage the space that they're in, and manage movement around the world, and handle broadcasting that information out. So we're going to throw it in JS again. New file, we'll just call it server.js. And give you a bit of an introduction to Node.js modules. So we're going to use a couple of modules to make it easy for us. We're going to use socket.io. Socket.io has an abstraction over a couple of techniques to allow us to do communication with WebSockets, and if you're the latest version of Chrome and you don't conform to the right spec for WebSockets, then it goes back to XHF polling, and there are other options that you can use. So for our... Sorry, just through my notes here. We're going to create a variable called IO, and we're going to require socket.io. I changed my notes from the implementation earlier. It's always a good thing to do. Okay. Sorry if I do copy and paste a little bit. It's fairly short on time as it is. So we require socket.io, and we tell it to listen, and we've got this GS object that we're going to create. That's game server. So we've got game server settings port. Then we configure it and tell it that the transports it can use is only WebSocket. Just use WebSocket. And the reason we're doing that is because if Chrome tries to connect, it'll use XHF polling. XHF polling can happen, maybe 30 seconds apart, and the player updates are just, they're really annoying to see 30 seconds apart, and it's not useful. So what we need to do is also create our game server object. With settings. Yeah? Okay. Is everyone okay with a little bit of copy and paste? Yep. All right, cool. That's heaps easier then. So we've got a settings, we've got a port, and we're going to keep a reference to clients. That's pretty much it. So once we've done that, what we say is we attach an event listener to say io.sockets on connection. So every time there's a new connection, run this bit of code and pass in the socket for the client. Okay, and that's all we're going to do right now. Just say connection established. And if I go into I'm in the JS directory, I need to do an install of the module socket.io. So we say npm is the node package manager. npm install socket.io, and that goes and grabs that module and actually just dumps it in the current directory, so you can add it to versioning and whatnot. So that's got it. If we do a directory listing, we can see we've got node modules now. Okay, so it's just thrown it in there. If I try and run node server.js, we can see socket.io started. Very simple, very simple. We might just see, make sure that it's accepting connections on the right port. Okay, so it connects. I can tell that to it, it's connecting, it's working fine. It doesn't recognize the connection because I haven't done a handshake and said, hey, I'm using the WebSocket protocol. And that's fine. So that's all we can test for the server right now because the client's not connecting yet. Okay, so the next thing is to make the client connect and at least manage that connection properly. For this, we need socket.io. Because we're using socket.io for the server, we also need the client to be able to connect to it. The cool thing about this is that I'm running it on localhost, so I can actually say localhost on the port that I'm running it on slash socket.io socket.io JS, and it will actually serve the JS off the node instance that I just started. So I can run that, make sure the server is running, start our client, view the source. You can see there's the socket.io JS for the client. So that's come across very easily. Okay. Now we're actually going to try and create a client. What we're going to do to start off with, and excuse me for looking at my notes, but we're going to basically set up the connection. So we set up a bit of a game client object, manage the connection. So in client.js, this is just a little, what am I doing cat for? What was that for?
Oh, Captain Jack.
Captain Jack is my cat, by the way. Okay, so we've got a game client object that we're going to start, and we're going to keep a reference to it. A couple of things we need to keep reference of when we're doing a game. We've got the players, so we need to keep a reference to the current player in the game. We need to keep a reference to remote players so that we can display them in the scene. We need to keep a reference to the socket for communication, and we're also just going to have some settings to hold on to if we need to reconnect at some point. So we'll create the socket. It's going to have an ID, and we're also going to have an object. So we'll just set them to null for the moment. Save myself a little time. Okay, so we've got settings and we've got the players. We've got local, remote. I've also got one here for parted that I was working on, so that when player disconnects, you can like fade out their player or something, or do something, hold on to their object for a little while and do something cool. And the last thing that we want to do is connect. So we haven't written connect yet, but we will write it right now. So set up all the objects that we want to keep reference for, set up everything we need, and then call the connect function. Whoops. If you see me doing that, let me know. PHP program, I keep putting brackets instead of writing the function bit. So our connect function needs to just basically call io.connect with the right address. So the right address equals, it's http / self.settings.host. Sorry, if I do put a dot as well, let me know. It's a PHP thing. And self.settings.port. Okay, so that's our address. So it's going to be http / localhost / 8081. Okay. The socket is going to be io.connect to the address, and we'll return the socket. So a nice encapsulated function there to connect, generate the address, connect, return the socket. Very simple. The other thing that we want to do with that is to register some event handlers, and I'll throw these in here. We want to register when these are events that I'm creating. So connected means that the socket has connected. Player connected is one that I'm calling for when any player in the game has connected. So the server can send this event. Player disconnected for when any player disconnects, and position update for when any player moves. This is as complex as our game example can get today. So we'll register those, and I've got some functions that we are going to write ourselves: socket connected, player connected, disconnected, and socket receive position, so that we handle that data as it comes in. Okay, so then to start this client, we need to basically create an instance of it. So new game client, it's expecting some settings, and we want host to be localhost and port to be 8081. Okay, so our node instance is running. Let's refresh the... So I've just refreshed the page, and you can see that handshake authorized. So the connection's been made. Code's starting to look different between the two windows. Okay, so there's a couple of things. Our HTML page at the moment contains nothing, really. It's got some scripts. We need some stuff to display things. We need to display the renderer, essentially. The renderer, best placed inside like a div or something. Just place it into a container so it's nice and separated. But we're going to start adding things to our game client constructor. So we'll say self.createContainer. Okay. And all that's going to do is create a div. So document which is essentially what I wrote in my notes. We might keep a reference to it. Not really. It's you just have to do a get element by ID or something instead of what I'm going to do here, which is maintain a reference. Yeah, there's no difference. So the container, then we add the container and return container. So create a div, add it to the body, return it. Okay, so then we'll just keep a reference to it. So we've done that. The next thing we need to do is create a scene. We've got a place that we can put the renderer, right? But now let's go and create the scene. So we'll do self.scene. Just keep a reference to everything. Okay. Now the scene, if you remember, is what we're placing all of our objects in. And it's actually very easy. We're just going to do a basic scene. We're going to call 3JS for the first time. Return a new scene. Okay, so that's just going to create a scene object from 3, return it, we'll keep a reference. Next thing that we want to do is create the main scene. So this is the scene object. We need to create, when I say create the main scene, it's the scene that represents our current level or something. We would use the same scene object and refresh it. You'd empty it and then put new objects into it to change levels. So we're going to create the main, our game essentially. Main scene. Okay, so what we want in the main scene to start off with is just the player. Let's just have the local player as an object, very simple. So we'll call it create player, and the cool thing that we can do with this is we can actually pass information about objects through Node.js. So for this one, we're going to say size 100. So it's a setting we're going to pass to create player, which we have yet to create. Then we're going to set the position on it. So player should return a mesh. A mesh is a set of vertices that are defined in triangles for the renderer to display, which we don't need to know too much about just yet, but we can set a position on a mesh. Okay, so we now set a position for the player to be 0, 0, 0. It's a new 3.vector3, so it's just that three-dimensional point in space. And then we need to keep a reference to it. So self.players.local is one that we defined earlier, equals player. And we need to add it to the scene. So self.scene, which we created just before, .add. That's not right. I am missing a semicolon. Semicolons are optional though. Yeah, okay. So it's the object for the player position. Okay, so we create the object, we set it onto the game client to say this is my local player, and then we add it to the scene. Now, I'm going to refresh the browser. You can't see anything. That's normal. Don't stress out. We don't have a renderer and we don't have a camera. Okay? This is bootstrap process you need to go through with any game client like this, any 3D environment. So we need to create our create player method. Actually, this one's fairly straightforward. He says copying 20 lines of code. What this one does is it passes in some data, so we're passing in a size. I might just highlight that so you can... Okay, so what it does is it checks that data being passed in to see if it's got a type set on it. If the type is set, if the type is not set, we're going to generate a random number. This type will be the type of object we appear as in the game. So I've got down the bottom here, you can see I've got a cube, a cylinder, and a sphere. These are our player objects that we can be in game. It also randomly generates a color. So this mess here is just a random hex color generation. What it does there is it sets the type, and then it generates some basic materials and mesh. So the material is one that comes with 3 called mesh basic material, and you set a color on it. So it's a flat color, nothing fancy, but good enough to get us into a bit of game development, get 3D stuff. We generate a mesh and we just pass the object into it. That object is the 3.cylinder or 3.cube. So it grabs that information and generates a mesh out of it. And then when we return, we set all the data that we had for it. So we've got the object, we set that to be the mesh, the type, and the color. So we return all of that information as an object and we store that. Okay, so now we've got one of 3 types of objects as our player in game. Okay, so we still need a camera and a renderer. We'll go ahead and create the camera. Try and keep my constructor thing very simple, but verbose at the same time, just so it goes through all the steps. Okay, so we need to create a camera object. We're going to use a perspective camera, and 3 provides us with some defaults. Okay, so a new perspective camera, and we'll pass it some options. So these options can look a little bit confusing. So the first option is the field of view. the angle of the frustum. And okay, frustum. So a frustum it's a rectangular pyramid, essentially, and it's sliced off the top. If anyone's seen a US $1 note, it's got one of those on it. So we've got a concept of a far plane and a near plane, and it represents what you see in a computer, and actually what you see yourself. You've got, my frustum is about that big. I can't see my hands. So it goes out to a certain point. The far plane is where you stop rendering objects. The near plane is as close as you will render objects. So you've got this particular defined piece of space that objects can appear in to be rendered. What we're doing is defining the angle of that, and we're going to define the near plane and the far plane, and we're also going to define the something or other, the aspect ratio. So you define the field of view as the up and down angle, and then the aspect ratio figures out the rest. So 65 is a good field of view. It looks reasonably natural. Our aspect ratio is just going to be based on the window. Okay, so we just use the full window so we get that exact aspect ratio. Our near plane will be 10. Our far plane, we might set it to 3000 or something. 2000 will do. Okay, so that's our settings for the camera. That's all set up. Our frustum is configured. We need to set a position for the camera. Now this is where local and world space come into it. We're going to set it at, we're going to lock it to one coordinate just for simplicity. So it's going to be 0 on the X. On the Y coordinate, which is up and down, and 3 actually handles the reversal of the coordinates for us, we're going to set it at, say, 250 up in the air. So we're creating a third-person perspective here. And then we're going to set it 500 off in the distance. So we've, from the point of the player, we want to go up, and then we want to go out. So you end up looking over it a little bit. So we set that position. The next thing you need to do is tell the camera, at the moment, if we go up 250 units and back 500 units, at the angle of the frustum, it's actually going to appear right below where the text, under where near plane says. It's going to be just out of the frustum because we're looking over the object now. So what we want to do is tell it to look at something. We want to look at self.players.local object position. The local player object position. So just look at the player. That brings it down, so it rotates the camera for us. Rotations, if you have to handle them yourself, can get pretty tricky. So it's handy that it provides these for you. The next thing we need to do is we want it to be in the local space of the player, because we want the camera to move with the player. So we add the camera to the player as a child object. Local, thank you. So we add the camera to the player, and then we return the camera. Okay, I'm going to completely skip the render and copy and paste that in. So the renderer creates a canvas renderer, which is just a specific type. We're just going to use canvas. It adds it to the container that we added, and we need to say self dot. Okay. Yes, it is a software renderer. Okay, so we've got a renderer, we've got a camera, we've got a scene, we've got objects. Everything's been added and everything is fine and perfect. We've done it all right. So when you refresh, you get nothing. Okay? What we haven't done is told it to render. Okay? So the concept of game loops, you can get into some pretty heated discussions with game developers on how to correctly manage game loops. Don't tell anyone I do it the way I'm going to do it now. Basically, I'm just going to go at a fixed frame rate and the game logic is going to go at the same rate. It's just simple to use set timeout in JavaScript to do it. So what we want to do is, once we've got our client down the bottom that we create an instance of, we're going to say run and give it a frame rate. So we might give it a frame rate of 30. That's it's fairly reasonable. And then we'll create a run method. That's going to be frames per second, yeah. So the browser can handle up to about 120 for stuff that I've done. I'm rapidly running out of time. There's 20 minutes left, but that is not much time. So I'm going to comment that. That's something we're going to do in a bit. So what I'm going to say is on our run function, so we're calling it and passing 30. That's our frames per second. When we call it, we say self.render, which we will write in a sec. So it's going to render every time that run is called. It then does a set timeout and passes in an anonymous function to call run again. The reason you need to do that is so that you can call a function with arguments after a set timeout. And then this is the calculation for frames per second. We want one event per 30 seconds, times it by 1,000 because it's in milliseconds. Okay, so that will handle our loop. The only thing we need to create now is the render. It's very simple. Self.renderer.render, pass it the scene, pass it the camera. Render this scene with this camera. And it doesn't work. Okay, we've got some errors. Oh, okay, yeah, sorry. Up here where I said to append child. Okay, so when we refresh, we've got a randomly generated shape, kind of, out of 3 shapes, and a random picked color. So if I refresh, I've got a cylinder, different color, sphere, there should be a cube in there somewhere. Okay, so and you can see it's got that perspective look, getting smaller at the back, and it's very quick. It's very quick. So that's the basic object. There are a few optimizations we can make. You can actually throw in a console.log to see how many times that frame is being how many times it's being rendered if you're not sure if it's rendering properly or not. There are a few things that we shouldn't do, and that is currently we're rendering everything on the scene. We really should be only rendering things that are in or almost in the frustum, because anything that I can't see behind me, I don't care about as a renderer. That information being rendered and using CPU time, that's a waste. So we want to cut that information out. So you generally cut up your scene into segments and then check whether the frustum intersects these segments and then render anything in those segments. That's scene management. So the next thing that we do is we want to be able to control it. I'm going to copy and paste controls as well. Sorry about this, guys. So I've got all this movement stuff that I've made. I've got essentially all the settings. So if you're doing any key controls especially with browsers, but games in general, rather than just saying if the W key is down, move forward, you don't want to do that because it's going to be essentially interrupting with events and it's going to be a little bit jerky. So what you want to do is say on key down W, say that movement forward is true. Then on key up W, movement forward is false. So that you're only flagging it on and off once, and then between loops, it always knows that it's moving forward. And it will flag not moving forward when the key comes up. So I've got some key codes here.
It means there's that benefit if you can press the space bar faster than your opponent can do it.
Well, yeah, if you're shooting something, you wouldn't do that. Yeah, definitely. So I'm going to copy this movement stuff into the top here. And we also need to set up the events, which we did copy in as note. So we need to capture those keyboard events. Okay, again, this is boring stuff. I actually flagged this for copy. It is just looking at keyboard events and mapping them certain places. So, for example, key event, if the key code is keys.forward, set the movement flag forward to be whatever the state is. So the state that we pass is down here on key up and key down, we pass true or false. So down is, yes, we're moving that direction. False is, no, we're not. ignore the motion. No, don't ignore the motion one. We need the motion one. What we do is, based on the position and the movement flags, we say, we're actually not doing any vector stuff really. We're saying direction dot and whatever the position is. So forward is the Z coordinate that's into and out of the screen. We either -1 or we +1 based on forwards or backwards. And then when we're done, we basically do a vector addition for the direction at the end. So once we've generated that direction object, we then add it to the player's position. Okay. We also have some networking stuff there, which I'll just comment out for the second. Okay, so what we need to do is call that motion method. So motion moves if we've got move flags available, if they're turned on. So each time we render, we're going to call motion just before we render. So if I refresh, see what's happening? Looks like nothing. We've got a locally positioned camera looking at the object, but we are moving. So I'll quickly dump in some reference objects so that I can prove it and not just make it look like magic. Okay, so I've got some reference objects that I've pre-created here. They're just cubes, rectangular prisms. And I'll just add them to the main scene. So when we create the player, we're just going to add some additional reference objects so that we can see what's going on and we can see that we're moving around. And that's, I mean, for a web browser and for 30 minutes, that's not too bad performance-wise. It's 30 frames per second. We could jack it up a bit, but you can pretty quickly see what happens if you lower the frame rate. It looks like you're playing on my computer at home. Yes.
How do you deal with someone holding down forward and back?
So right now I'm moving off in a diagonal direction. I'm holding S and D. Okay, so I'm going to move back holding W and A. So A is left, D is right. So I'm holding W and A. D being right, I'm going to hold down D as well. So it's offset the position. So it corrects that because it's just saying move one direction that way, which leaves me right where I am. Okay. There are more intelligent ways to manage that, but this really does the job. Yeah. Okay, so we can move around. I can prove we can move around. Networking is the next thing. So while we've been running this, we can see we've got handshake authorized. So each time I've refreshed, it's done a handshake. It's connecting to that server, so that's working. We've got heaps of time actually, depending on how we write this server. The server is very, very simple. When I think about game servers, when I originally thought about game servers, or servers in general, it was a little bit difficult for me to understand everything that a server needed to do. What should it be responsible for? How does it communicate properly with clients? And what data do you send? What don't you send? And so I've thought about this for a little while, and turns out it doesn't really matter at the scale that I'm working. But you really do need to think about movement specifically. This example, the client is sending its position. Something that we've got in the client that I commented out is to send position update. So a send position update, the client is sending its position to the server. And that's not too much of a problem, but if you end up with someone that's hacking your environment or your game, or there's some way to change, there might be a business application. I'm not sure what you'd use the 3D.js stuff for. I'm primarily using it for games. But if your client is responsible for indicating where it is and what it's doing, its rotation, its motion, that's not a good idea. Trust it like, deal with it like any form, any data coming in from the user. Don't trust it. You can understand that they are moving forward, they are moving left. You might want to pass that information rather than the position. With that information, you can tell the client to move and then send the directions it's moving to the server. The server calculates the real movement and sends a position update back to the client. So to explain that a little bit differently is the client is making a prediction. I'm moving forward, so I'm going to take a step forward. Okay? And I'm also going to let the server know that I moved forward. The server calculates, based on him moving forward, he should have taken a step forward, one step. It sends me back a position to say, you should be at one step forward from where you were. But if I say, I'm moving forward, and then update my position to be across the room, when the server comes back with its checked movement, it'll say, no, you're actually supposed to be back here, and it will correct me. That's how we get smooth motion in these sorts of environments. We do a prediction, this is how I'm supposed to move, but validate from the server. Ends up being a little bit of communication back and forth. So on our server side, all we've really done is got this on connection. What we want to do is I'll run through the whole lot. So we've got a list of clients in gameserver.clients. We loop through the IDs that we're storing, and the IDs are socket IDs. And then for each one of those, so for a new connection that comes in, the server says, for all the existing clients that I have, send out an event, so socket.emit player connected. That sends out some information about the player. Sends an ID, position information, type and color. Now, the session ID from the socket that connected, that caused that event, isn't yet in the client list. So this emits to all other players. Or should. There might be a typo in that. We'll try it. What we then do is we add that socket to the clients. So we now have a reference to the new socket that came in. We just emit a connected event to say you've connected. And then once that's done, we send out player details. Oh, sorry, no, socket.onPlayer details. The client sends out player details. So the connection here, it's a bit of a handshake. So we do the protocol handshake. Then we do a connection. The server sends back to us to say, yes, you are actually connected to a server that's speaking this game protocol that we're building. And then the client will respond to say, these are my player details. Here's my type and color. And here's where I am at the moment. And trusting that position is fine. So once it's updated its player details, we say to everyone else on the network, this player is connected with this information. Every time we've got this position update that we send from the client, every time that is received by the server, we broadcast that to everyone. Socket.broadcast, say it's a position update from this particular ID, and pass the position. So a client updating their position and sending it to the server is being broadcast out to everyone. Each time we do that, we want to just store the position as well. And then each time we receive a disconnect, and this is handled natively by socket.io, we just want to send a broadcast to say the player was disconnected so that we can clean up the objects that were left hanging around. Okay, we've got 5 minutes. I want to show you a practical demo of this, so I am going to switch across to, here's one I prepared earlier. And I actually need to kill that one and go... Okay, so got a cylinder, that's fairly simple. Why is that so difficult to grab? We're going to end up with a weird aspect ratio, but that's fine. Okay, so what I've done is my default for rendering new players that connect on the client is a size of 50 for the player, and the current player is a size of 100. So you can't actually see them because they're actually sitting behind. So you can see between the browser, you can see real-time movement and position. And so that's happening. You can see in the background here all this WebSocket information. You can see all the position update, this particular ID, X -1, sending all the coordinates. Yes?
You can press that using where the microphone
Yeah. Socket.io handles natively compression, so it'll handle that for you without having to think about it too much. I was told that I was going to get a wireless access point from a friend to get you guys to connect in and test it with me, but unfortunately I don't have that available. But you can see that's very smooth for a 1 hour demonstration. The types of objects that I've rendered are just the defaults from 3.js because I didn't want to go into model loading at this point. But you can just replace those cube, cylinder, and sphere calls that we made to a model loader and pass it a model file that you've read in. And that is just a one-liner. And so you can load in a complex object.
So if I know nothing about Blender, how long is it going to take me to get something resembling my face floating around in an environment like that?
Well, not knowing Blender, getting a representation of your face might be a problem. But yeah, any object that someone has created for you, if you've got exported into a common format like the Collada format or the 3ds format, or there's a ton of standards, you can use any of those and do imports. 3JS handles that. There are also other alternatives for 3D in JavaScript, but yeah, 3 handles stuff like that. Yes. What's my IP address? I already tried that from my iPad, but
You're serving Node.js on localhost.
oh, good point. Good point. Server. Where are we? I'm just saying a port, so it should be.
No, it may be a big problem with localhost if you're setting, not setting a host name or anything.
Oh, right. Okay.
I don't know how Node handles that at all.
I'm not sure how to set a host name. We are at.
Can't you just say 0000?
It's just attaching to a port, so I'm not sure if there's 2 settings for it, or if we have time to look at the socket.io documentation. I'm really interested to go through this if anyone is interested at all, and I will be hanging around, probably catch me out smoking. Please stop me from smoking, get me talking about this. But yeah, we are running out of time. We've got 2 minutes for questions. So, yes?
Can you just let us in the browser and demo something more complex you've done before?
Yep. I'm trying to give a good example. There's one good example of a 3D tile-based engine that looks like it looks like those 2.5D platformers. There's an engine for it out there that's open source. So I'm trying to think of the name of it. Grab me after, and I've got a link to it somewhere here. I just need to find out where I've put my files. Okay, this one's a little bit tricky. It uses mouse control as well as keyboard control, and I have a shift modifier to go faster. So that doesn't look like much, but I'll zoom forward, and this might look familiar from my slides before. Because it's a lot of point data, it's just rendering as points. This is part of the Kempsey LiDAR data, which doesn't look really useful. But the LiDAR data is so massive that I've got a key here to load in the next segment. So it loads in the next segment. I can keep doing that, and it exponentially gets slower because I'm not combining this information together to render at once. But this is a good example where you do have larger environments and a lot of information. You need to go through a little bit more to say, pull apart these meshes and combine them together for one render call. Doing this much information in one call is very, very quick, but if you're doing each individual piece one at a time, it's a lot of bandwidth back and forth between the graphics card. So that's an example in Chrome, and it does move. It's just a little slow when you've got that much data.
So
That's it.
Time we have now. So please, thanks, Graham.